So I'm going to take up a bunch of the different types of compounds here. So I did post this. This was just a mixture of everything. So I thought I might as well take up a few of the different types so that you could see, just to make sure that you're on the right track here, okay? So the first one, I'm going to do the first one, okay? So offhand, looking at it, hopefully you can see, okay, well, this is a polyatomic here, right here. So that polyatomic is acting as the nonmetal. And then we have cobalt, okay? Now, cobalt is a multivalent metal. So you might not know that because cobalt's not one that we use very often in these. So these are the kinds of things that you should always double check just to make sure, okay? So you see, all right, well, cobalt and nitrate. So first off, because, yeah, we have a 2 here, all right? Just before we go and assume that cobalt is the 2 charge, just double check to make sure what the other one is. Though it is a 2 because cobalt is either a +2 or a +3. But you always want to double check just because, again, it's an ionic compound, and ionic compounds are always put into the lowest term. So you want to make sure it wasn't just put into a lowest term and you end up writing the wrong number. Okay? But nitrate is just a -1 charge, so that's right. So this cobalt we're using is cobalt with the 2. All right? So when you go to do your name, it would be your cobalt 2, and then you would do your nitrate. Okay? Sorry, my bad. I said nitrate, but it's nitrite. It's 2, it's not 3. Sorry, so it's nitrite. Okay? Okay, next one. Always kind of double check, too, which one you're dealing with. So here, calcium and oxygen. So calcium we know is metal, oxygen non-metal, it's an ionic compound. Calcium is not multivalent, so you don't have to worry about putting the Roman numerals in. So all you can do is just go calcium oxide. Done. Okay? All right, so this is one actually that I know that kids have done before. So when you've just come off of polyatomics, you can look at this and be like, well, this is a polyatomic. You know, it's sulfite. But the polyatomics ions have a charge. This does not have a charge. So we are looking at a molecular compound here, not the polyatomic sulfite. Got it? If there's a charge there, then it would be an ion because it would have a charge. But it's not. So it's a molecular compound. There's no charges. All right? So it's molecular because sulfur is a nonmetal and oxygen is a nonmetal. So now we're looking at it. Okay, so sulfur. There's only one. So we're just going to put sulfur. I'm going to go with the F version here. FUR. And oxygen has the 3 attached to it, so it's trioxide. Okay? Nitrogen and sulfur. They're both nonmetals, so let's go with that one. So we got dinitrogen. There's only one sulfur there, so monosol. I'm going to switch it up and go pH this time, sulfide. Okay, we don't need to go through all of these. I'm just taking a little gander here to see which ones are multivalent, just because I like to try to do multivalent ones. Okay, let's do nickel here, okay? So nickel, phosphate, right? So the 2 was attached to nickel, remember, and the 3 was attached to phosphate. That was the charge up here, and that was the charge over here. So nickel is one of those multivalent ones. So it was the nickel was the 2. So you're going to go nickel 2 phosphate, right? Because it's a polyatomic, and the polyatomics we do not change the name for. I'm just looking for another maybe molecular one that we could do. Okay, so ones like this, remember, this is oxygen gas. Okay, here, this is a good one. So phosphorus and sulfur, okay? So the 4 tetra phosphorus, I always get that spelled wrong, And then penta sulfide. I'm going to go pH because I prefer the pH actually. Okay, and then last one is because I saw this one and I like these ones with copper. We use copper a lot. And you'll see that there is no charges on either. There's no subscript here for copper. And copper is either a 1 or a 2. So this is where you have to go and check what sulfate was. Okay? So, sulfate is actually a -2 charge. Okay, so which means that since there isn't a subscript down here, we put it in lowest terms, which means that copper was also a +2 charge. Okay? So this would be copper. Why did I spell it like that? Copper 2 sulfate. And it's spelled with an F. I'll do it. Okay? Okay. Hopefully you kind of getting the gist of this. So let's go to the trickier one because you have to find the charges for these ones. Alright. So, sodium phosphate. Okay, so how I've taught kids in the past when they're looking at the names and writing formulas, put the charges above it. So sodium is a +1. And then phosphate is a polyatomic and it's a -3. Okay? So it's going to be sodium 3, and then you have your phosphate, PO4, but you don't have to put the 1 in, so it's done. Okay? Aluminum carbonate. So aluminum is +3. Then you're going to go and you're going to check out carbonate, which is a -2. So you're going to have your aluminum 2, okay? And then you have your carbonate, CO3. Don't forget the brackets. And then you're going to do your 3 on the outside. Okay? We're not putting them beside each other. We're not adding them up. Okay? Calcium chloride. So calcium is +2. I'm just making sure. Yeah, +2 charge. Okay? And then chlorine is -1. Okay? So we're going to go calcium and then chloride. Okay, let's look at some, since these are all ionic here. Let's start to pick out some that are, okay, oh, this is a good one. Ammonium chloride, because ammonium here, ammonium is one of the only ones that we use. We don't use hydronium, which is the other positive one, but it's one of the only ones that substitutes for the metal as a positive ion, right? So ammonium is a +1 charge. Chlorine is a -1, so you don't even have to worry about the subscripts. But ammonium is NH4, and then we have chloride, and that's it. Antimony, so we have this one here, which is giving us the Roman numeral, okay? And it's telling us that it's a +3 charge, and then we know bromine is a -1 charge, okay? And then, so then you're gonna, so then you're doing your crisscross with it, and then we're doing no 1 because we don't have to put the 1s in, and bromine with 3. Oops, sorry, it's Br, my bad. Otherwise it's boron. So Br3, okay? Let's go over and do some of the not polyatomics. We've done some of the polyatomics. Sorry, I'm getting confused here. It's late again. I'm just seeing with the molecular ones here. Okay, so dinitrogen trioxide. I think we did this one already. We did. It was on the other one. N2, because remember this is for the nitrogen, and then the tri is for the oxygen, right? Easy. Iodine, so there's nothing with it, so it's just your I. And then pentafluoride. So remember, penta, like pentagon. So we have our FL5. No L. Yeah, no R, sorry. So IF5. Okay? Alright, so let's see. Phosphorus triiodide. Phosphorus, there's no mono in it. So when it's blank like this, we know that it's 1. And iodide is 3. So we have phosphorus, which is 1, and then our I, which is 3. Nitrogen trichloride, again, there's nothing in front of it, so we know that it's a 1. And then our chlorine, which is 3. I'm just checking. Phosphorus pentafluoride, so PF, but there's a penta, so you're going to put your 5 in. Nitrogen, so there's nothing in front of nitrogen, so it's N. And then we have our oxygen, which is 1, so it's just NO. And then sulfur dibromide, so we have our sulfur, which is 1, so we don't put anything. And then our bromide, which is 2. And then diboron, which is good, so it's 2. And then tetrahydride, that's our hydrogen, and it's tetra, so we 4. Okay? So I think that's enough there. Hopefully you're able to follow through and figure it out as you go through. If you're still confused and you want me to go over more with you, then pop on to the Google Meet and I can spend a little bit more time taking up a couple other ones with you guys, okay?